Alright, this is chapter 4, section 2, example 16. So in example 16, we look at another home loan, but this time we're going to use something called points. The lender charges points, so that makes it work a little bit different. So what we have to do is we have to figure out what the face value of the loan is. Okay, that's our first step. But first thing we have to do is read the problem. So a couple borrows $140,000. So that goes at the beginning. With an interest rate of 5.1% compounded monthly. So our I is going to be 0.051 over 12 for 20 years. That also means that we have monthly payments. So 1 month in we have a payment, next 2 we have a payment, all the way down. Okay, and then our total number of payments here is going to be 12 times 20. So number of payments per year times total years. There's no overlap here in years. There's no SN. Home loans are straight AN problems, so we don't have to worry about any manipulation there. So now we're ready with all of that piece. But before we can calculate R, we have to figure out what the face value of the loan is. So to get the face value of the loan, we're going to take okay, because this isn't going to be this one, it's going to be F. So F is going to be equal to the amount borrowed over 1 minus the points as a decimal. Okay, so if we do 2 points, it's going to be 0.02. Okay, so it's like a percent. Okay, so again, big picture. F equals the loan divided by 1 minus the points divided by 100, because that converts it to a decimal. Okay, so this is again another formula that we haven't necessarily talked about. Okay, points aren't used quite as much, they're not as popular, you're not going to see them as often, but just in case you encounter it later in your career, I want to make sure that we touch on it. Okay, so that means this is going to be 140,000 divided by 0.98. So we get 142,857 and 14 cents. Okay, rounded to the nearest penny. So I'm just going to rewrite that because that didn't look very nice. 142,857 and 14 cents. Okay, so this is our face value. And that's what we're going to use right here. So the F is going to go at the beginning and take the place of the loan amount. So now we're going to find the monthly payment. So we already have everything else we need. We already have I, we already have N. So then our R is going to be I 0.051 divided by 12 over 1 minus 1 plus 0.051 divided by 12 to negative 240. Times our F, so 142,857 and 14 cents. So doing that on our calculator. So our monthly payment is $950.71, rounding to the nearest penny. Okay, and then we're going to take that, or sorry, rounding up because it's a payment. So we're going to take that, and now we're going to find the effective interest rate. So the effective interest rate, we dealt with this before as the EIR when we were converting things. It's not how we're going to handle it here. The effective interest rate we're going to treat like the internal rate of return. We first learned about that. We called it the IRR, and that was in section 1.5 if you need to review your notes. Okay, so what we're going to do is we're going to take our loan, not F, and we're going to set that equal to our A sub N, okay, with the payment that we just used before. So our loan amount is 140,000, and that's equal to 950.71 times 1 minus 1 plus point R over 12, so So negative 240 over R over 12. Okay, again here the idea is we're trying to find R. Find R, that's our internal rate of return. So we're going to set this equal to 0. Just like we've done in the past, because it's a little easier to compare with how close or far away we are, instead of having these numbers with lots and lots of digits. And we're going to start with our R is 0.51, because that's what we had in part A. So I entered that in my calculator already, so it's all ready to go. And I'm just again testing my A, testing my formula. Okay, before I add in that 140,000, just to test it. And I notice I make a mistake, so I can fix it now. I forgot to put over 12 up there. Okay, so let's try again. There we go, that's the number we want. Okay, so we're going to take this, so we're going to subtract off 140,000. So that means that we still have in there 2,858 and 12. So we ask ourselves, should we go up? Should we go down? Let's try going up, see if we get closer to 0. So we're going to try 0.052. I'm going to store that as my A. So I change it. I'm going to do my same entry, subtract my 140,000. Oh, we got closer to 0, so that's the way we want to go. This time we got 1,674 and change, so we need to go a little bit bigger. Okay, let's see, that would be 1, 3. Okay, so let's try 0.053. Store that as A. Run it again. And we get 504, so we went down pretty significantly this time. 45. Okay, let's try 0.054. Oh, now we're negative. Okay, so that means that it has to be between these two values because we passed 0. Okay, so it's got to be between 5.03 and 5.04. Okay, so let's go straight in the middle, try 0.0535, because we usually want to go to 4 decimal places. Store that as my A. Run it again. Whoops. Negative 75 and 8 cents. Oh, that's pretty close. So we're still a little over, so let's try 0.0534, because that was the positive direction. So we'll get closer to 0 because we have a negative number. Run it again. Now we get 40.55. That's pretty close. And again, here we've gone over, so the 0 is going to be between here, but we're only going to go to 4 decimal places, so we just, since we've gone already to 4, we can just take whichever one is closer. So between 75 and 40, 40 is closer. So then our R So again, we're doing 4 decimal places on the table, and then we pick whichever is the closest to 0. Okay, so here closest to 0 would be 40 versus negative 75. 40 is closer. Because you're taking the absolute value of those and comparing. So that means R is 0.0534, and whenever we find a rate, we always write it as a percent, so our final answer would be 5.34%.